Have you ever wondered what makes the music from your headphones, the chirping of birds, or even your own voice possible? The answer lies in the fascinating world of sound waves. Let's dive into how these invisible ripples in the air create the symphony of life around us. At its core, a sound wave begins with vibration. Think about plucking a guitar string. As the string moves back and forth, it pushes and pulls on the surrounding air molecules. This creates areas where air molecules bunch together, called compressions, and areas where they spread apart, called rarefactions. This pattern of compressions and rarefactions travels through the air like a wave in the ocean. But unlike ocean waves, sound waves don't move water up and down. Instead, they create a pressure wave that moves through a medium, usually air, like a series of invisible dominoes. The speed of these waves depends on what they're traveling through. In air, sound moves at about 343 meters per second, but it travels much faster through solids and liquids. This is why you can hear a train coming by, putting your ear to the railway track before you can hear it through the air. The characteristics of a sound wave determine what we hear. The wave's amplitude, or height, determines how loud the sound is. Higher amplitude means louder sound. The frequency, or how close together the waves are, determines the pitch. More waves per second create a higher pitch, like a bird's chirp, while fewer waves per second create a lower pitch, like a bass drum. Sound waves can do some pretty amazing things. They can bounce off surfaces, creating echoes. They can bend around corners, which is why you can hear someone calling from another room. They can even transfer energy, which is why a loud bass can make objects vibrate. In fact, everything around us is constantly vibrating at different frequencies. Most of these vibrations are too subtle for us to see, but when they create sound waves in the right frequency range, our ears can detect them. Our ears are incredible instruments that can detect these pressure changes and convert them into electrical signals that our brain interprets as sound. From the quietest whisper to the loudest thunder, sound waves are the invisible messengers that connect us to the world of sound. Understanding sound waves helps us create better musical instruments, design concert halls with perfect acoustics, and even develop new technologies like ultrasound imaging. Next time you hear your favorite song or the laughter of friends, remember that you're experiencing the remarkable journey of sound waves, transforming simple vibrations into the rich tapestry of sounds that fill our world.